Now what we're going to do is we're going to look at expected value. If you look at the definition of expected value, you'll notice that the definition is exactly the same thing as the definition of the mean, because the mean is long-term or long-run expectation. And so in these word problems, what they tend to do is they tend to use the wording expected value instead. And so that's kind of your key phrase that'll let you know that's going to be one of these problems. So all you have to do is take x times p, x times p, x times p down the whole table, or what you can do is the little one-var stats L1, L2 trick that I showed you on these previous problems. So just know that mean and expected value are exactly the same thing. So we're going to do 3 examples, and they'll be similar to what you're going to see in your homework. Okay. So this first one says you have an insurance policy that charges an 18-year-old male $350 for a 1-year, $250,000 life insurance policy. So those are the important numbers that we have. So it's going to charge him $350, and if he were to die within that year, he would get, well, his family would get $250,000. Then they're going to give you probabilities. So it says the probability that an 18-year-old male would actually survive the year is 0.998937. So pretty good chance, nice 18-year-old healthy male. Okay. So it says calculate the expected value or the expected profit, and this word profit is important, okay, of the life insurance policy to the insurance company. So we want to look at this from the perspective of the insurance company. So what we have to do is we have to create a table, and these tables will not be given to you. You're going to have to know, like when you get the homework, it's like this. You're going to have to know to create the table yourself. The first thing you want to do is you want to think about, okay, what are the different outcomes that could happen at the end of the year? Well, there's one outcome, and that is that this 18-year-old male could live, and the other outcome is that he could die, right? There's only 2 outcomes, live or die. Now, when you're talking profit, you have to do some sort of subtraction, okay? So the first thing is, in terms of profit, if this 18-year-old male actually lives through the year, the insurance company gets to keep this $350. That's straight profit that they get to keep, okay? So that would be $350. They would get to keep, and it's positive, $350. And the chance that they get to do that is 0.998937. So most of the time, they get to keep the $350. But what happens if this 18-year-old male were to die? Well, they would have received $350, but then they have to pay out $250,000. So if you think of it like on a number line, like if this is, we'll say this is 0, they're going to get $350, but then they're going to have to pay out, I know my picture's not to scale, they're going to have to pay out $250,000. So what we're looking for is the difference in those. So if we take 350 minus the 250,000, they're only actually going to get that much money. It's the difference between what they would pay out and what they brought in, which was the 350. So it's going to be negative $249,650. That's what their profit would be. Now, how do we figure out what this other probability is? Well, there's only 2, and we know they have to add up to 1. So if this probability is 0.998937, to get the other one, you just subtract from 1. And we're going to get, and you got to write out all those decimals, 0.001063. And you would try to make sure that those actually do add up to 1, and they should. Okay. All right, so now that we have it, the probability table that we just created for profit is this. And there's 2 ways that you can go about getting your answer. You can do x times p, and you can add them together, and that's not really too difficult to do. Let's see, 350 times the probability plus, now make sure this one's negative, you can just X times P, and add them together. That's one way to do it. $84.25. That's how much money they would expect to make off of one of these policies in the long run. Or your other option would be to go to your tables here. Delete out what we had from before. Put your 350 negative, make sure you hit the negative button, not the subtraction button. Negative 249650. Now it's going to change it when it puts it here, but don't worry about it. It's fine. It does scientific notation, but if you scroll over it, it still remembers your number. And then here, you put your probabilities. And again, I know they look weird, but they've rounded them off, but it's still retained what those numbers are, okay? And then you can do one var stats L1, L2, like we did in the previous section, and you still get, it's the top number, $84.25. So whichever way you'd like to do it, it doesn't really matter. These tables aren't going to be very long, so if you want to just multiply and then add, you can do that, or you can do it this way. The point is, it's $84.25. And so what that means is if they sold a whole bunch of these policies to a bunch of 18-year-old males, they would expect in the long run to make $84.25 profit off of each one of those policies. And this is how they set their rates, right? So maybe they're not happy with that. Maybe they want to make $100 per policy. Well, they're going to have to raise their rates. They're going to charge more than $350. And you better believe there's somebody that works for the insurance company that's back there trying to figure out, because they know these probabilities, trying to figure out how much they would profit so that they can set their rates. That's like a very common practice in insurance. So if it says profit, you have to do this little subtraction bit. If you put negative 250,000 here, you're going to be off by just a little bit, and it'll be just enough to drive you crazy on MyMathLab because it's going to tell you that you're wrong. Okay, so make sure that you do that subtraction. Let's look at this one. It says, this one is different because it's talking about winnings. It says you're going to play roulette. You're going to bet $2 that the ball is going to land in space number 11. So remember, this is that big wheel with the red and the black slots, and there's 38 slots on the roulette wheel. And you're betting on space number 11, and there's only one space number 11, and you're betting $2 that it lands on that space right there, space number 11. So the probability that it lands on slot number 11 is going to be 1 out of 38, because there's only one slot number 11 out of the 38 slots on the wheel. And remember, when we're doing probability, we always use a 38 slot wheel. Now if you win, you're going to win $20, which is awesome, right? So you bet 2, but you win 20. But if you lose, you're not just at 0, you're actually at -2 because you lose that money that you bet. So now it says calculate your expected winnings. We want to calculate the winnings. Well, with winnings, we don't do any subtraction. Okay, you don't want to do any subtraction on these or you'll miss it on MyMathLab. So there's two outcomes. You're either going to win or you're going to lose. That's what happens when you make a bet. You either win or you lose. If you win, it tells you right there, you win $20. So don't overthink it, just put $20. If you lose the bet that you made. So it's worse than 0, it's -2. You should always have a positive number and a negative number in this first column. See, we had a positive and a negative here. There's always like a good outcome and a bad outcome, all right? Now, as far as the probabilities go, the probability of winning is only 1 in 38. And we know that these probabilities have to add up to 1. So if 1 out of 38 will make you win, then that means 37 out of the 38 would make you lose, okay? Because these have to add up to a total of 1. So 1 out of 38 and 37 out of 38. Don't do any subtraction. If you do subtraction, you're going to miss it and it's going to drive you crazy. All right, so this is our chart. List 1, list 2, if you want to do it that way. Again, I'll show it to you both ways. You can do 20 times 1 out of 38 plus negative 2 times 37 out of 38. You can do it that way. Remember, this is money. So negative $1.42, that's what that tells you. Basically, you're losing money because this is a pretty risky bet. You don't win very often, so you'd be losing money. Or you can go in here and you can put 20 and negative 2. Now, when you do these probabilities, go ahead and just type them as fractions and let the calculator handle the decimal part of it. So we type 1 out of 38. And then we're going to type 37 out of 38. You just let the calculator deal with whatever the calculator does. Okay. And then you go one var stats, L1, L2, and you still get negative $1.42. So it's going to be the same answer, regardless of which way you do it. So your expected value is that you're going to lose $1.42 every time you make this bet. In the long run, you're going to lose $1.42 on average every time that you play this game. Now, MyMathLab likes to ask a follow-up question. It says, if you play the game 1,000 times, how much would you expect to win? Well, if that's how much you'd expect to win playing it once, then playing it 1,000 times, all they want you to do is take 1,000 and multiply it by your expected value. So if we multiply that, you just move the decimal over. That's how much money you would expect to lose if you played the game 1,000 times. Okay. Normally on tests, I'll just ask you to get to here, but on MyMathLab, they do go that extra step and ask you to multiply your answer by like 100 or 1,000 or whatever they ask for. Okay, so that's how much you'd expect to lose. So generally speaking, if your expected winnings are less than the bet, it's not generally a good bet to make. That's just sort of kind of standard rules when it comes to gambling. But all right, so that's winnings. Don't do any subtraction, just $20 and a minus 2. Okay, let's try one more. This one says a couple purchases a foreclosed property for $50,000. And then they spend $27,000 fixing it up. Okay, spend that on renovations. So if you take these two amounts, they spent $50,000 and $27,000 all together. They have spent $77,000 on this property. Okay, that's how much of their own money they've invested in this property. All right. They think they can resell it for $120,000 or $100,000 or $80,000, and the probabilities come with them. See, this is a contrived textbook problem. Calculate the couple's expected profit. So again, there's that word profit. You have to do subtraction. So there's two outcomes. They're either going to sell the house or they're not going to sell it. But it goes a little deeper than that. They can sell it at different prices. So they could sell it for $120,000, or they could sell it for $100,000, or they could sell it for $80,000, or maybe they just don't sell it. So those are some options. Okay, we'll see what all the probabilities and all the profits are for those options. Okay. Let's fill out the probabilities first of all. For $120,000, if they sell it for $120,000, the probability is 0.15. $100,000, the probability is 0.45. See, they have a better chance of selling it at that price. And at 80, 0.25. So the question is that all of the options? Like maybe not selling is not an option. Let's see if we add that up. 0.15, 0.45, and 0.25. No, see, that's only 85%. So would that make the don't sell probability? It would make it the remainder, the 0.15 remainder. So these are the four options, okay? Now we do need to figure out what the profits would be, okay? So think about this. If they sell it for 120, but they put $77,000 into the house, you have to think about what's their profit. Let's see. $120,000 is what they made, but they put $77,000 into it. So their profit is only $43,000. Again, we're having to do some subtraction because it says profit. So they sold it for that much, but they put 77 into it. So 43,000 would be their profit. They'd make money. What if they sold it for $100,000? Well, we're going to do the same thing. Take 100,000 minus 77,000. 23,000 would be their profit. Still pretty good profit. Maybe this next one we can do in our heads. If they sell it for 80, but they put 77 into it, they'd only make $3,000. And if they don't sell it, they're sitting on $77,000 worth of debt. So this one has to be negative. Remember, one of these will always be negative. Okay? Here's our table. All the probabilities add up to 1. You can do list 1 and list 2, or you can just multiply across and then add them all together, however you want to do it. I'll do it that way. Make sure you make that negative, that last one. $6,000. That's what I get. $6,000 expected value. Now let's do it the other way and see if we get the same amount. Let's see here. Okay, so I've got my table in there. Notice that the last one is negative, negative 77,000. Get that all in there. One of our stats, L1, L2, $6,000. It's the top number. So y'all do it however you're more comfortable doing it. I know one of these will end up on the final though. So $6,000. What that tells these people is if they were to repeat this exact scenario over and over and over again, they would expect to make $6,000 per house in the long run on average. And that's what expected value is. Remember, with profit, you need to subtract. If it's winnings, you don't subtract.